All right, friends, welcome. My name is Will. I am a part-time accelerated instructor, and I am the Azure specialist for Coding Dojo. And welcome to our our DP-900, so our Azure Data Fundamentals workshop. This is, again, a workshop that is going to focus more on data, how data is handled in the cloud, things we can do. It will have a data science portion, so really kind of talking about the tools that are available to data scientists and analysts. But this will really just be a great overall understanding of how data is stored. So as you guys are building applications, you can understand, what the different data types are doing, and maybe even just get a different understanding of the different data types. So just wanted to say welcome there. Excited for this. A couple of ground rules as we get started. We always like to say teamwork makes the dream work. We will be working in groups occasionally. And so for some of the assignments, we'll be doing sort of group work, not assignments per se. We're going to be doing some kind of jumping into groups and learning and growing and developing stuff. So teamwork makes the dream work there. With that comes humility as well. Obviously, if somebody makes a funny question or maybe something that's obvious to you, but not quite to them, we're a group here trying to grow and trying to better ourselves. So just as a reminder, maybe don't laugh or kind of make fun of somebody there. When it comes to the cloud, especially if this is your first understanding and first really like interaction with the cloud, it might be a struggle at the beginning. And just as normal, you guys are alumni of the dojo, so you've heard this a million times, but there is strength in the struggle, right? There's strength in learning and growing and understanding when something doesn't make sense to process through, to grow through that, and then to understand it. There is a lot of strength in that. So, there might be a struggle, but that is what is going to be, it will be helpful for you in the long run. And the last thing is respect. I'd love if your cameras are on. If they're off, totally okay. But I do ask, stay on mute if you are in a busy area or, a loud area, just kind of helping as I am teaching. It respects me as the instructor, but then it also respects your fellow students, which is awesome. Cool. A little bit of housekeeping. This is the tentative schedule. Sometimes we'll go early, sometimes sometimes we might go through the material a little bit earlier. And so this is a tentative schedule. Now, I will say that if you are planning your day around the schedule, let me know, right? Let's say you have to pick up kiddos or you have somebody coming over, you coordinated a lunch or a meeting from 12:30 to 1, and then all of a sudden we finish 30 minutes early and then things kind of come back. Just let me know, right? Because if it alters from this, just let me know. And that's just kind of an overall thing. If you've got to step out, you got to take a work call or something like that, just DM me through Zoom chat and let me know, and that's totally fine. But here's our tentative schedule. We're going to be doing a morning session. We'll have an entire lunch. There's a break within each session as well. Have a lunch, and then we will have an afternoon session. We typically will be done around 3:30 to 4 o'clock-ish PDT. So that's just something to sort of keep in mind as well. Cool. So in this workshop, we're going to be learning about like the core data concepts, how data is handled in the cloud, and the big thing is how Microsoft Azure Data Services works and the tools that Azure specifically provides for us. There are different clouds, right? There's AWS. I'm sure you've heard of that. That's Amazon's. And then there's one called GCP, which is Google Cloud Provider. A lot of those have similarities, right? Azure, AWS, GCP have a lot of similar things, but the real difference and the real indicator on kind of market share are the tools that these clouds provide, right? The tools that Azure can provide for, whatever you're trying to do. And so we're going to learn about those specifically. After this, you will be set up pretty well. And we say about 85% of everything you need to learn from the exam, you will get from this workshop. There will be a little bit of, kind of on your side to walk through some of the material to kind of make sure and reinforce some of the concepts or the tools to use. So there will be that portion there. That's on you. And then after, you can take a certification. Now, the certification is intense in some regards. It is a proctored certification, meaning that somebody will be with you as you're taking it. You will have to download an application to make sure that you cannot surf the web. You will have to show your entire desk to show that you don't have notes or you don't have anything you can cheat with. and that sounds kind of intense and a little bit is, but what's nice about it is it gives a lot of validity to your certification, right? It's not something that you just went online and you could Google the answers and, it's like, oh, I'm now certified in JavaScript. But it's like, do they actually know JavaScript? We don't really know. Like, they could have cheated, but by it being proctored and it, kind of being, you can either take it in person or it being proctored, it gives validity to know this person knows these concepts, right? They understand these concepts. They understand how data is handled. They understand the tools that Azure has. So after this workshop, do a little bit of studying and you can get certified. And that looks great on your resume. It looks great in your LinkedIn. Recruiters see that, and that's a really big kind of indicator and tool that, hey, this person is also continuing their education, which is really great. And there's I'll send you these slides. I'll put this in the chat, but there is also a link there on the source, and now the links are in the chat, that show that there's actually a huge uptick for Azure certified developers. Azure is number 2 in market share behind AWS, but it is the largest provider, meaning that it has the most data centers, it has the most regions of any company. And so a lot of people are actually sort of switching to Azure. And so this just kind of increases your market potential. And this is a third-party source that you can read about there, which is awesome. So learning objectives for this workshop is to kind of prepare you, is to prepare you for the DP-900 exam and to get certified there. You're going to learn how to work with data in the cloud. And again, the specific Azure offerings for the different types of data. So the different things that we can do with data, you're going to learn what Azure, kind of some general understandings of data, but then what Azure specifically is going to do, which is awesome. And then at the end of this, right, as long as you stay for all of it, and or, if you've got to dip out 15 minutes early, that's totally okay. As long as you, participate and are part of this, you get a 50% off voucher, which is $50 basically. So as you're taking the exam, it is $100 to be certified, and the certification lasts for 2 years. You will get 50% off. So I'll send you a coupon tomorrow. And then as you go and you set up, and we'll talk about how to, where to input that coupon XYZ, but it'll be worth $50 for you. So that way you can get certified for cheaper, which is awesome. Cool. Just a little bit about the exam before we get started with what is Azure. The exam, I believe you have 60 minutes for the actual exam time. It is a multiple choice or a drag and drop. And so there are aspects there to, drag and drop, and we'll kind of walk throughout this workshop. We'll walk through some of the stuff of, this is what the exam will look like. This is what the, a question might look like. So, here's what that looks, here's what to kind of prepare for. This entire workshop is built off of the exam, right? And off of our experience of taking the exam. And our experience of studying and what you really needed to know and what you didn't. So we try to help you as much as we can there. And again, it does last for 2 years. Whenever you set up the exam, because it is proctored, you do typically need about 24 hours to set it up. And so you will go in, you'll find a time. And then once you find that time, you can basically, once you find that time, then you set it up, and then a proctor will meet with you and then go through that exam. Cool. Any questions kind of on the setup of this? And I do like to not just give a workshop. So if you do have questions, you can either raise your hand in the chat, or raise your hand, or I think there's a little something to, I think you click participants and then you can raise hand, and then that'll let me know, that'll alert me that there's a hand raised. Or you can just put it in the chat. I like to stop kind of halfway through or after each sort of section concludes, and I check the chat if there's a question, and I'll try to answer it as best as I can. Cool. Well, I guess let's just go ahead and get started sort of with the basics. So first of all, does anybody know what Azure is? I kind of talked about it a little bit, but if you want to put in the chat, or if you want to come off mute, any idea of what Azure is? If you've taken another workshop, then we probably have gone over this as well. Any idea what Azure is? Yeah. Yeah. Azure's the cloud, but specifically, it is a cloud platform designed and provided by Microsoft. Right. And so, like I was saying, the cloud is just a word or a term to sort of describe servers hosted somewhere by some other company. Right. And so, just before we even dive in, if you attended the AZ-900, then you are aware of this. And if you didn't, this is kind of just an introduction. Back in the day, right before we had this idea of the cloud, if you wanted to host a application or a database, you would have to have the servers on your premise, right? It's called on premise. So, at a building or something you had to own and you had to set it all up, and it got really sort of expensive and complicated. And then as we've evolved, there are companies like Microsoft and AWS or Amazon and Google that had, kind of said, instead of you having to house and, set up and maintain these servers, why don't I do that? And you just pay me a subscription fee, right? And what that has done is it's allowed a ton of companies who maybe didn't have the network understanding or capability or the capital to really just spend thousands of dollars on servers. Now, instead, they can just add this into their monthly subscription model. And then now they can, use and have the benefits of having your own servers and having your own network there. And so what Azure is really just Microsoft's version of that. So Microsoft houses the servers, they maintain the servers, they make sure that there's security, they make sure that there is security both on the servers and, physical security. That way people aren't, tampering with your data, with all of your information. Servers can run hot, so you have to make sure that the room is cold and at a certain temperature. Azure maintains that, or Microsoft in itself maintains that. And then they have them all over the world. That way, you have the best and most optimal experience for your employees. If you have an application that, or not employees, but your customers, if that is something, that you desire to do, like quickness is something that's super important. And so Azure in itself is just Microsoft's version of that, right? And according to Wikipedia, Azure is a cloud computing service created by Microsoft for building, testing, deploying, and managing applications and services through Microsoft managed data centers. Cool. Any questions on what is Azure? Cool. Just again, talking a little bit about the exam. There is a exam. This is what we're kind of working for. You're going to take the data fundamentals exam, and then you will get certified. This is what the certification looks like. Like you get this little shield, and then you can put that on LinkedIn, which is really, really awesome. Diving deeper into the exam, it's 50 to 60-ish questions. I think 55 is the norm. You get 90 minutes. What that means is it's 60 minutes for the exam, and give yourself an additional 30 minutes to kind of get set up with your proctor and make sure that, they're going to ask again for you to kind of show your desk and make sure there's nothing that you can use to cheat, like another computer or, XYZ. You do need to schedule it in advance. When we're looking at the exam, this is really how it breaks down. This comes just from Azure's website. And so this is sort of, again, what we focus on for this entire workshop is, 15 to 20% is core data concepts. Now, that doesn't mean that every single one of them has 18%, right? It does vary because there are different versions of the exam, but here's how the breakdown is. And that's kind of what we're going to focus on. And then here's just the learning path, maybe things to, as you're studying, to make sure that you learn, you understand, and these kind of main things, and then you can take and get ready and set up for the exam. There are some resources. Again, you guys have these slides. So if you wanted those resources, they're right here. This is what we're going through, but there is a learning path. Just something to sort of reiterate. If you've never used the Microsoft material, not only can, you don't just have this workshop, but you have a lot of material that Microsoft gives to you here, where you can go, you can start these, you can sign in. I'm not signed in right now, but you can sign in, keep track of all your points, which is something that's kind of cool. You can share like, oh, I'm learning, and put that on LinkedIn if you wanted. But then here's just ways that you can dive into the material. There's a, do this overview. You can learn, you can review. And then what's cool is there's also a knowledge check. So you're not just aimlessly reading, right? But you can actually make sure that, okay, here's something, didn't really know this question. Let me go back and reread that to really dive in. So there's an entire process. Those are all linked here. So for the 4 that we just showed, all 4 are linked here, and there's different, different things associated with that. So this one learning module has all these different parts. Cool. Again, here's our tentative agenda. From 9 to 9:30 is our introduction, which we are just finishing up with. So we're right on time, which is great. Then we've got about an hour of me explaining core data concepts. Now, this is going to be the heaviest time of me just talking and teaching. And so sort of just to prepare you there. Then we're going to have from 10:30 to 10:45, we're going to have a break. And then from there, we're going to have another 45 minutes where we do some group work. So you're going to dive in and really get your hands kind of getting familiar with the material, familiar with the Learn platform, the Microsoft Learn platform. Then we're going to do a knowledge check, which is just a fun way to kind of test and make sure that we know stuff, and kind of recap, right, and review. And then we're going to have lunch. So again, we're going to see, we're going to do as much as we can here. Now, this is not necessary if you don't want to. It's just a tool we try to provide for you, and I just put it in the chat. But this is just a core data concept study guide. This is something we've designed for you. So maybe as I'm talking, instead of you just sitting there, right? Because we understand that from a learning perspective, listening to somebody talk for an hour and a half or whatever doesn't really help you retain the information. So what we did is we created this core data concepts study guide to where maybe if I'm talking about what is data, what are the different types of data, what are transactional systems, what are analytical systems, you can really just write this, and it's a way to keep track and keep your notes. Again, not necessary. You're not gonna have to turn it in or anything like that. But this is just something that you can do and learn, or as you're studying, maybe it's not during this workshop, but as you're studying, maybe you want to go through and add questions or add answers or XYZ. So it's just a way for you to kind of have a study guide there. Again, that's in the chat. You don't have to do it, but it's just a tool that you can do. Any questions on the setup? If not, we can jump right into the next section. Oh, let's jump on in. Okay, so does anybody have an idea of what is data? I want to put it in the chat. Like, what is data? Any type of information? Yeah, that's a great one. Anybody else? Recorded information? Yeah. Yeah, those are great. Those are both right. Information and recorded information are definitely a way that you can sort of describe data. If you think about it, data is everywhere, right? Everything can be some data. But here's one that we've just sort of settled on as a description. It's data is a collection of facts, such as numbers, descriptions, and observations used in decision making. And so data is just a collection of different ideas, right? Or different things such as numbers, descriptions, and observations. You think of how data works in Facebook, right? Did they click on this post or not? The data of how much does somebody make? How much does, you even go from like numbers, and currently we're in, the COVID crisis, right? And so like the data of how many people have COVID, how many people are vaccinated, XYZ. So all these numbers are all data. And if you really think about, your life and your everyday things, there's data points all over the place, right? If I pick up my iPhone, there is a thing that tracks how many times I pick it up, how many times I look at my phone, right? Then it gives me an average, gives me graphs. And so all of this stuff, how many times do I slide? How long do I scroll? How long am I on an application, right? So data is all of these different pieces. And so this is just a overall description, but data can be a lot of things, right? Which is kind of cool. And when we're thinking about data, there is really, and we're not talking about like the data theory, but more of, okay, if we have data, right? There's really 3 ways or 3 descriptors, or I guess I would say models that it falls under. Data would be either structured, semi-structured, or unstructured. And again, when I say this, I don't mean, like the arbitrary data, but more of, okay, if I'm recording how many times this person picks up their phone, what type of data is that? And it's one of these three. And we're really going to focus on these three, and we're going to dive in. So the first one would be structured data. Now, this is tabular data that's represented by rows and columns. If you guys took Python, you really understand this likely for your MySQL, right? Every instance of my data is a row, and each row has the same amount of columns. And that's the real big thing with a structured data, right? Even if I just look at this example on the top table for row 2, right? This Mr. Keith Harris doesn't have a middle name, but because this is structured data, that middle name has to be still there, right? Keith Harris doesn't have a middle name, but it still has a middle name column that just happens to be null. And so with structured data, it's every row has the same columns, right? It has the same identifiers. It has the same columns regardless. So that way it is structured, it's set up, but it's typically, it is tabular, right? So it looks like a table where we really focus on each row as an instance and column is like an attribute or a descriptor. Then there's something called semi-structured data. And if you did MERN, then you're probably aware of this, right? And this is information that doesn't reside in a relational database, but still has some structure to it, right? And so when you did MERN and you used MongoDB, you had documents to where they can look very similar, right? This one has a customer ID, name, but you can see the difference here is for document 1, this has a first and last name. And you see at the beginning of document 2, this one has a title. This is an additional attribute that document 1 doesn't have, but because it's semi-structured, that's okay, right? It can have different attributes in the same way that if somebody has a middle name or they don't, that data might change, right? Not everybody has to have a title, as we can see. And so that's where it can be semi-structured data, but it still has some structure to it, right? There is some sort of, kind of understanding of this is all a dictionary and there's keys and values, but not every single key, like each document doesn't have the same keys. And the last one would be our unstructured data. Now, this is data that doesn't have any specific structure. You're really going to think about audio and video files here and binary data files. These are going to be the ones who, there isn't really a structure between a ostrich and a kitten, but these are just photos, right? They're just data points there. So that's going to be what we call our unstructured data. And with that, each database or each type of data has a certain type of database. And there's really two types, right? There's relational and non-relational. Again, if you think of a relational, you think of maybe like a Python or a Java, where there's like your one-to-many relationships, right? And then when you think of non-relational, you're going to think of like if you took MERN, that MongoDB, and there's other types as well for non-relational database. So those are kind of applying what we already know to the different types of databases. So right now we're going to focus on the relational database piece. Again, this is information that's held in tables. If you've worked with MySQL or you had to jump into MySQL Workbench, you're really familiar with this. The table contains rows, and each row is a single instance. All the rows in the table have the same columns, just like we saw with the middle name. Even if they don't have a middle name, they have a middle name column that just might be null. And then some columns are used to maintain relationships between tables. Those are my foreign keys, right? Where I am relating a book to an author or a user to a post or something of that nature. And it looks just like this, right? Where my customer maybe has a customer ID, a customer name, a customer address. And let's say we're using or buying something, right? We are Amazon, and let's say we're using a relational database for that. Then I might have a table of products that is like a shirt, a tie, and a collar. And then together, let's say I have this looks like a many-to-many, right? Because a user can buy many products and a product can be bought by many users. So what I would have is a third table called orders that then associates the two together. And the way we do that is just through my customer ID and my product ID. That should be, sort of kind of a recap of what you guys learned in Python or Java. But that way, this is just a way to show that I can have different tables and I can associate them together. The real big thing that we associate by, because it's the most unique, is the ID number. And as you can tell, this order, what it does to associate, okay, this customer with this product is going to be the ID numbers there. So some of the main characteristics of a relational database is that, again, the data is tabular, right? So it is like a table, where we've talked about that each instance is a row. Now, normalized tables relate to each other in a schema. Normalization, something that we sort of talked about in Python, but it's where I can break out my tables to make sure that I am not repeating myself often. So you can kind of think about it in the same way of a user and an address. Let's say I've got multiple users at the same address. Instead of me having to house that information multiple times, what I could do is I could normalize my data to where, okay, I've got a user table and I've got an address table. And if a user has this certain address, now all of a sudden I'm just calling that address ID number instead of having to save the same city, the same state, the same zip code, the same actual address number and house number, et cetera, et cetera. So that's called normalization. A table can contain any number of rows, right? It doesn't have to, there's not necessarily a limit there. The primary key is what identifies us. That's our ID, right? And then the foreign key, again, is what is referencing another table, just like we saw with the order, where we have the ID, the customer ID, and then the product ID. That is going to be our table, but then maybe we have just a one-to-many that has a foreign key, and that is going to connect my user to my product, something like that, or book to author. And just something to note is that, again, creating a database model for a large organization is not a very trivial task, right? It's pretty difficult, and it can take several iterations to define tables to match characteristics described above. And again, kind of talking about that idea of normalization is where I might need to split it out to where I don't want to repeat myself. But one thing to note is you can take normalization to an extreme, to where, let's say I have an address. I could, in theory, take that out even more and say, okay, I could do a city, right? Where I've got my city's got a population or whatever, and a city name. And then in my address, instead of having, street address or house address, the street name, the city name, the state name, I could have, my city to where it's now referencing my city table, and then my state's referencing my state table and all the cities and all that stuff. So you can't take normalization too far. So it is a fine balance of sort of, okay, what is too much and what is, great. And do we need to really, if you guys took Flask, you would understand joins. And so you could tell, like, if I had a state, a city, a neighborhood, if you normalize too much, joining all those tables together would actually be more complicated than, no, I'm okay with sacrificing and just having an address and a user table. Cool. In a relational database, an index helps you search for data in the table. So you can kind of think about that like the front of the book or the back of the book, right? That tells you where certain things are. So it will help you reference an item or reference a certain instance in your table, which will be super duper helpful. You can kind of think about it this way, right? The index is going to be like, okay, I want to search for my customers. I want to search for this certain customer ID and all the things that it's associated with. So that'll be my index. If you guys took Flask, then you are familiar. You will, for the exam, need to sort of understand some MySQL, or just, sorry, not MySQL, some SQL code, right? And so if you guys took Flask, you understand what is going on here. But if you didn't, I'll kind of explain. What this code right here on the left side is doing is it's saying select, right? And what it's wanting to select are the order ID and product ID. So just these columns. So the values from orders, which is my table, where, so this is sort of my filter, the customer ID equals C1. So what it's going to do is it's going to go into this table. It's going to grab all of the column, all the data for order ID and product ID, where this customer ID equals C1. So it's just going to grab all that information and that's what it's going to return to me. So on the exam, what it might do is say, it might be like a drag and drop and say, like, okay, how would I, where would I select? Like, you would drag, if orders are here, like, okay, get me the order ID and product ID from the orders table, where, it'll kind of lay it out, and then you would have to drag and drop, like, okay, no, it's select. This is the column names from orders, which is my table. So you do have to know the very basic stuff like this for the actual certification. And what I can do is, let's say that's something I commonly am doing, right? I'm commonly checking one specific users or one instance. If I'm at a company and maybe I'm a sales and I'm a sales branch, right? And I want to get just my team's sales, right? Or my product. Let's say instead of the sales thing, let's say I'm a product, right? And I sell on Amazon and I just want to see my sales. What I can actually do is, if I'm setting this up, I can actually create what we call a view. And what a view is just a virtual table based on the result set of a query. And so basically it's just a window for specific rows. So maybe I can just set up a view if it's something repetitive, like a query that I'm going to typically run a lot. I can set up a view, and that's just going to be sort of like a table with just my information, my specific information based off of my actual main data, which is something that can be kind of cool. Something that, again, it's the idea of like, instead of having to query the database every single time, you might just be able to create a view that then helps you understand and see the results quicker. Cool. So that is a relational database. Any questions on a relational database before I jump into non-relational? So in some situations, you actually don't have all the required knowledge of the structure of your data. And so like in advance of it actually arriving. So you might not know everything that's in your data set or all the data that's been collected. And if I don't know that, I can't set up really the columns. I can't set up the rows. I can't set up, or not the rows, but I can't set up the columns properly in like a tabular format, because, if I haven't looked at my data, then I have to go through and say, okay, what does most of these have? If not, does it have null? And I'd have to kind of set that up. But a much, 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 much more efficient way, if I don't know exactly what my data is going to be set up, is to use a non-relational database. Because if I'm just getting a data set and I don't know what that looks like, then I can use a non-relational data set, because it doesn't matter, right? What sort of material or what sort of data it does have, I can just call it quicker, but I don't have to set up this tabular kind of system. So sort of key aspect of non-relational databases is they're able to store data in a very flexible manner. So again, they don't have to have the same columns of information or attributes, right? It can be, this one can have a first, a middle, and a last name. This other one just has a first and last name. This other one just has a first name. That's okay. Non-relational databases are not going to care there, because they don't impose a schema on data. And what a schema is basically just a blueprint for what the data is supposed to look like. So if I, in Flask, you created maybe a model, right? Or you went in and you created an ERD of how it's supposed to look like. That's your schema. Non-relational databases don't have that, because there's not a blueprint of what it's supposed to look like. They're willing just to work with whatever they have, which means that we can actually store data very naturally, which can be quick, right? Which can be quick and efficient when we try to query and use the data. You might hear non-relational databases known as NoSQL databases, or yeah, you might hear NoSQL. And that's kind of a loose term when we're dealing with data, especially in the cloud, because NoSQL typically, that will refer to a non-relational database, but there is some debate, because is it not only SQL or not SQL? The reason is because some non-relational databases actually support a version of SQL queries adapted for documents rather than tables. So like Azure specifically has a tool called Cosmos DB that allows you to do some SQL queries. So kind of querying some information on a non-relational database. So on documents per se. And so that's why there's some debate of not SQL or not only SQL, to where, if you, and I kind of lean on the not only SQL, because, yeah, you might be able to use a tool like Cosmos DB that allows you to do some different version of SQL queries, but you can look it up other ways, especially if you looked, if you took MERN, you know what I'm talking about. But you can still do that. If you have the tools like Cosmos DB, you still can do SQL queries, an adapted version. And so I like the not only SQL, but up to debate. So when I do say NoSQL, I just mean a non-relational database. They're going to be interchangeable there. There are a couple of the different ones. There's really 4 that we're going to focus on here. Document is what you have used if you did MERN, right? So that's the one that you're the most familiar with. But then there's 3 other ones. There's key value, column family, and graph. And we're going to go through these. And then for this portion, it really is going to be imperative to understand not only the type of NoSQL database, but the tools that Azure has for that database. Because a part of the exam will be, okay, not only are we questioning, what is a key value or whatever, do you have that understanding, but what tools in Azure support that? And so I'll be kind of hitting both there. So for a key value storage, it is the simplest and often the quickest type of NoSQL database if I want to insert and query data. So the way, it kind of sounds like the name, right? You've got a key and a value. That's just 2 elements, right? You have your key and your value. You can quickly identify just sort of the item by whatever is in your key. So if I call this key, it's going to give me that value, which can be very, very fast. What the difference is, though, is I can't filter beyond that, right? So if I say this key A to the 5th, right, I get the entire value. If I were to say if the key was an ID of a person, right, you can kind of think about it that way. Let's say it had this, user ID, and then they had a first name, a last name, an email, a password, address, whatever. I get all of that value. A key value is quick, but I can't filter out. Let's say I just wanted the first name. I can't do that, right? If I use a key value database, I just want the value. I just get the value and all of the value. I can't filter, anymore. You can kind of think of a key value database as one that would be great for like readings, right? Let's say if I'm doing like a temperature reading, or if I'm doing some sort of, analytical reading where I just want the key, right? And then it will give me the value at that reading time or something like that. I'm going to want that entire value, or maybe I'm just storing really just the value of that, temperature or whatever. That'll just be quick, something I want to read quickly. That would be a great time to use a key value database, because they are fast and they are, sort of efficient to save and to query. But again, just the big thing with a key value is when you query and you get a key, you have to get the entire value. You cannot filter you can't filter within the value. You have to get the entire thing. So Azure Table Data Storage, that is going to be the tool that is an example of a key value store. One thing I will say is Cosmos DB is something that that's the most generic. Cosmos DB does almost everything. It's kind of your catch-all. So most of these are going to be also Cosmos DB. But the real thing with a key value database is this Azure Table Storage is an example of a key value store. Cosmos DB allows you to do that via the table API, which is just going to basically query this and call this like storage. So Cosmos DB does allow that if you want to use the table API, but Azure Table Storage is an example of the key value store. Next is we have our document. So it's on the other side of the key value store. So it is each document has a unique ID. If you did MERN, it's going to be exactly like what you dealt with, right? Where you've got this ID, but in the fields within the document are sort of transparent to the database management. So if I query it, oftentimes it's going to give me something back like a JSON object, JavaScript object notation, I think is what that stands for. So it's going to give me JSON back. It might also be encoded as like XML or YAML or BSON. So those are the different formats, but JSON's your typical kind of gives back. And this one can be stored as plain text, which is awesome. But this is the one that if I've got my user and I want to go deeper into my user instance, and I just want the first name, I can get that, right? Versus the key value is I have to get everything. This one I can actually dive in and get specifically what I need from that user. It looks just like this, right? Where you're going to have this key. And then you've got your customer ID, your order items, et cetera, et cetera. And you can tell that some of these are different. You don't have to have specific things, but you can if you wanted. And if I wanted to get the, product ID or the cost of this first product or all my products, I could go into this document. I could go into my order items list. Then I'd go into the first one, right? Get the cost. And I just have my total cost that this customer has spent, something like that. I can do that because I can dive in deeper versus, again, a key value I cannot. Again, Cosmos DB implements a document database approach in its core SQL API. So again, because of this, you can do some sort of modified SQL queries on this information, but it's tool that Azure specifically has as the core SQL API for our documents. This next one is our column family database. Now, this one typically is confusing to students, just transparently, but basically it is a non-relational database that organizes data into rows and columns. So it looks very similar to a tabular relational database, right? I've got my row and I have my column. But really what it allows us to do is it allows us to take bits and pieces of my information and almost mimic a row and column tabular data to where I can take this column and I can join them together, put them side by side to make something new, which again, sort of feels like a relational database. It's not, conceptually, it sort of feels like that, but it's just a way that if I've got certain data that I want to connect in a non-relational database, I can using the column family database. Yeah. Any questions on that one? You can kind of see that here, if I wanted this, let's say I've got a customer info, right? Where I've got a name and then I do have some addresses. I can push them together. They still are non-relational, but I can push them together. If I'm saying, oh, these are associated to one another, I can push them together as like a quick sort of query and recall to that. Cool. So for the column family databases, it is the most widely used one is the Apache Cassandra. So that is a management system. Apache Cassandra is the most commonly used for a column family. And again, Azure Cosmos DB supports the column family approach through the Cassandra API. So the tool that Azure would have is that Cassandra API in the Cosmos DB database. And the last one is going to be a graph database, which allows you to sort of store entities, but the main focus is on the relationships between those entities or nodes, is what we actually call them. So nodes and edges. So our node is going to be our each like entity, and then our edge is going to be the relationship between the nodes, which I'll show you here in just a second. So they can both have properties that provide information about that node or edge, like columns in a table. Additionally, edges can have a direction indicating the nature of a relationship. And really an organizational chart, like a company org chart, is really the easiest way to describe that. Here I've got this node of Sarah, and I've got this edge where this Alec reports to Sarah, right? So I have this directional piece, but they are associated to where Alec reports to Sarah. Alec also has a relationship with the Department of Marketing, right? And John also works in marketing. It's node, but it has an edge. It's got a relationship, and it is related to Alec right here, right? Or reports to in this particular instance. And so a graph would be just a way to store this data in this particular way, to where, again, the thing pointing and showing the relationship would be our edge. And then within this is our node, right? Our entity of Alec, our entity of John, or entity of our Department of Marketing. And so you can see how an org chart works. Now in Azure, Cosmos DB does support a graph database using the Gremlin API. And so the way to sort of remember the graph in the column family is the column uses Cassandra, right? So CNC, and the graph uses the Gremlin API. And so that's going to help you create and query databases as well. So in Cosmos DB, you can use the graph or the Gremlin API to create and query a graph database. Any questions on those? Cool. So when we're dealing with data, we have to process data, right? And there's two real ways that we can process data, one transactional and two analytical. So when we're dealing with the transactional data processing, that's just a system records of transactions, right? Which makes sense. Transactions, a small discrete unit of work. They're often high volume, has to be accessible really quickly. So if you think of like Amazon, right, I need to access that order specifically very quickly. And then the work is often referred to online transactional processing. So you can kind of think about it as like a record, like a bank record. Versus analytical would be querying data and gaining a bigger picture overview information held in a database. You can capture raw data, use it to generate insights. An organization can use these insights to make business decisions. And then the tasks between analytical systems are data ingestion, transformation, data querying, data visualization. Sort of think about it this way of not something that I'm just trying to query quickly, but something I want to get the overall picture. Let's say my sales for Q1 or Q2, I might use like an analytical system to deal with that and then make insights and forecasts of, okay, we're trending upwards, or maybe I wanted to get the overall picture of Q4 for the past 3 years, so I can forecast and predict what I'm going to do from a sales term, this next year. Make data visualizations from there. The way it sort of works is this. Here's an analytical system. Let's say we've got some sort of data, right? Whether it's critical device data, financial transactions, or point of sale data. I'm going to do something called data ingestion. That's where I send my data to be ingested, to sort of be all in one area. Then I've got my data transformations. Now, this is where I have set my data, or I have cleaned, like I have to clean my data. And sort of I'm starting to transform it into what I need it to be. Then I've got my cleaned and transformed data. So I'm getting rid of maybe empty rows in the data transformations, or I'm doing something with my, my values that are empty, or, if I've got bad data, I kind of get rid of that. And then once I've got my cleaned and transformed data, I can either query it, right? And I can, use it to connect a user together, or I can set it up for visualizations. If I want to do some sort of graphs or some sort of, predictions, then I can use that. After that, if you take the AI 900 workshop for next week, this is where, with our cleaned and transformed data, I can perform, machine learning on that. I can handle that data, and it really sets me up for a time that really sets me up to be able to utilize that data well. Now, there's two ways that we really like that can describe the process of what I just said. There's one that's called ETL, which is extract, transform, and load, where the raw data is retrieved, right? That is ingested. We have that raw data. Then it's transformed. So we clean it, get rid of what we don't need, et cetera, and then I load it, meaning then I save it on my database. Now, this used to be the standard, right? Everybody would do this. You would take your data, you clear it, you filter it, you get rid of what the columns you don't need, or the data pieces you don't need, and then you load it into your database. And the reason was because we would, storing data was really expensive, right? Having your own servers, having all that. So we wanted to make sure we only stored what we needed, and we got rid of everything else. And that is our ETL. A lot of governments are still on this process, right? Because the governments are usually about 10 years behind, right? So they're still on this ETL format, but now most people have moved to an ELT format. That's extract, load, and transform. And so instead of, getting our raw data, then transforming it, doing everything we need, and then loading and saving that, good data, we've actually just moved to a way where we extract our data. We actually save all data, right? And then we do some sort of complex processing where we're transforming, and then we take that data and save it somewhere else. And this is really important because now with the cloud, we can save data very, very cheaply, right? Like it's not as near as expensive as it used to be. And so by doing this, we are able to actually save all of our data. And with the ETL one, maybe we got rid of some columns that we didn't think were necessary from our data. And then, our business model changes 2 years later, and all of a sudden this data that would have been really, really impactful and really good for our new business model, we've already gotten rid of, right? And that's why people have changed to this ELT, because now you are saving all data. And maybe you are doing specific things with that data where you are wanting to do one thing with a business venture, and you're doing some processing and cleaning, and you save it to another database, but you still have all that raw data. That way, if in 2 years, all of a sudden you decide you want to, make a shift or do something with the company and you need access to that really valuable data, you still have it, right? Because it's so cheap to now save data and have data that it doesn't make sense to clean it and get rid of anything that you might want to use in the future. So most companies are now on this ELT process to where you extract the data, you save and load all the data onto your database. You'd have your raw data, just everything saved, and then you start doing these transforming these processes. You save them in a brick or do some sort of machine learning or whatever, and then that from there you can save it in different databases that require or do the different things that you need. Make sense? Any questions on that? Great. When we're talking about data, there's really two processing types, and this one's really important. We've got our batch processing and our streaming processing. So batch processing is newly arriving data elements are collected into a group, but not immediately processed, right? So once the whole group, whether you've set it to like, once 20 instances, then run it, or I'm going to run it at a specific time, they're all processed together at a determined, way. So whether it's like, okay, at midnight, every night, I want you to process all this data. Or like I said, okay, once 100 entities happen or, 100 things, then I want it to run, or some other trigger, right? Some other event that you set up with your company. That's okay, at this moment, when this happens, or when the stock gets to this price, I want you to, process the data or something of that nature. So it's where it's not processed immediately, but it's processed in a group. It's called batch processing. Can you guys think of any examples where batch processing, kind of in your life, any examples where batch processing probably happens? You put it in the chat. Any examples of batch processing? The office, the coffee machine. Okay. Invoicing. Yeah. I think it's a great one. Yeah. You can think about like, I think a big one would be your bank account, right? Or a lot of financial companies might not process all of your, if you think of like a credit card company, might batch process all transactions at a certain time. And then all of a sudden your statement now reflects, your transactions or whatever that is. They kind of lean on a batch processing. Financial institutions typically lean more on the batch processing sort of way to handle that data. So yeah, great job, Tina. And then the other one would be streaming processing. So that is where newly arriving data is automatically processed as soon as it arrives. So it handles data in real time. So the minute that it gets it, it sort of handles it and processes it immediately. And it's processed as an individual piece versus having a lot all at one time. And then it's beneficial in most scenarios where new dynamic data is generated on a continual basis. So really quick, before we dive more into the streaming, one thing to sort of point out is batch processing might be great if you are trying to cut server costs, right? If you, let's say you have this really kind of complicated machine learning piece, instead of constantly running your server and having to do that, you might say batch processing for like a function on Azure that, okay, you only pay for, this computing power as you're using it. So, okay, let's just save it all once. run it for 10 minutes and then handle it, versus streaming is you are constantly processing your data. As soon as you get more data, you're processing it and you're dealing with it. Can anybody think of an example of where streaming processing would be really important? Social media, buying, selling stocks. Yeah. Patrick asked, batch processing would be useful for updating new changes. Yeah, that might be. Yeah, let's say, yeah, you can kind of think of batch process, right? Of like, let's say you're updating an application and there's multiple organizations working on the application. Well, you're not sending out a new update every single time, right? You're waiting until you get a certain amount of updates on the iPhone or your Android phone or, whatever computer. And then once you have maybe a certain amount or certain gigabytes or whatever, then you process and send it out. That's kind of a good way to think about it. Way to go, Patrick. Yeah, social media, buying, selling stocks. Yeah, you want to, especially these stocks, right? You're constantly processing the stock price, right? You not imagine if you waited and then it was batch processed every 3 hours, right? And all of a sudden you bought and then now it dipped in 3 hours or crashed or something of that nature. You need instantaneous processing. You need instantaneous processing from the stocks. That's a great one. Another one would be, you think about it, like if you go to the hospital, your heart rate monitor cannot be a batch process, right? You can't do it every 10 minutes because what if their heart stopped and they just haven't processed it yet, right? So a heart monitor or any sort of like health monitoring is going to be a streaming. You want the instantaneous data. As soon as you get that heartbeat, you want to make sure that you are showing it and you are, giving it. So that way, if it gets to a certain level, you can immediately act versus, again, let's say every hour it processed that. Well, they thought you were napping, but your heart stopped 45 minutes ago. That's an issue, right? And so you want to constantly be streaming that data and information. And so healthcare is a really, really good example of a streaming process. Also, like video games is another great example because you're constantly taking in data and adjusting to that. So that's another one as well. So, and this will be part of the exam because it's more of the tools that are provided for these jobs. But just to kind of throw this out there, data is a growing, a wildly growing sort of market within tech right now. It's kind of the new unicorn, if you will, that in cyber. So there are quite a bit of jobs out there. If you like data, if you like handling data, if you want to handle data, there's quite a few jobs. On average, data scientists do get paid more than a software engineer by a couple $1,000s, but the average pay for a software engineer is lower than an average pay for a data scientist. So if data is something you want to go to, or just money, it's a great area to go into. There's a couple jobs within data. There's your database administrators. They manage databases and assign permissions to users, storing backups, copies of data, and restore data in case of any failure. This is sort of a larger thing of really managing your database that you have, making sure that there's backups of your data. If there's a failure, making sure that it moves to this database or whatever, something that you are really like, this is a kind of the backstop of making sure you have your data available. Data engineers, they apply data cleaning routines. So they identify business rules, turning data into useful information. So like I was saying, going from the ELT, let's say we've loaded all of our data. Your data engineers are going to say, okay, I want to drop this column. I want to use this data. This is what I'm trying to do. I'm trying to forecast what we're going to be doing for Q4 sales of 2022. This is the information that's important to me. All this other junk I don't care about. So that's what a data engineer is going to do. And then a data analyst is going to take that data that the engineer gives, right? So the engineer is going to clean, manipulate, do whatever. Then a data analyst is going to take that and it's going to create visualizations and charts to enable organizations to make informed decisions, right? Looking at a bunch of numbers is not as impactful from a understanding standpoint as if I were to give you a line chart to show, trends, right? It's just instantly you can understand a line chart versus if you have to look, you might have to, okay, what am I looking at? Where am I trying to go? And then what a data analyst does is it takes data and it turns it into something that is understandable and quick. A big company that data analyzation is really large is Tableau. Tableau, that's literally what they do. You put their data and then you click buttons and say, I want a pie graph, or I want a line chart, or I want a bar chart, or whatever. And then Tableau will take your data and allows you, it's another tool that you can use to do that. Microsoft has a ton of tools for that. So from the database administrator side, there are some tools, specifically the Azure Data Studio. Again, this is like an exam sort of idea of, again, what tools does Azure provide? And for a data administrator, database administrator, this is also the person that's kind of dictating, if you're creating tables, like what's in there, right? So this is the Azure Data Studio provides a graphical user interface, a GUI, right, for managing many different database systems. So it has a GUI to where you can sort of set up everything, which is really, really cool. You can also use the SQL Server Management Studio to where you can back up quickly. Again, it's a GUI that enables you to query data, perform general database administration tasks, get scripts for automating database maintenance. So basically, maybe I want to back up every night at midnight. I can do that, right? And so I can write a script that just says, hey, every night at midnight, let's back up my data. That way, worst case scenario, my database fails. Maybe you might do it, every 12 hours, but worst case, you just lose 12 hours of data versus everything. And so, or you don't have to go in, every moment and do that. You can just do a script that'll run it for you, which is really cool. Cool. From the data engineer side, there's quite a few tools. There's SQL. So using that, right? So it'll provide tools that enables you to create and run SQL scripts. Again, this is the one where I'm dropping columns. I am manipulating my data to what I need it to do. And then the SQL Management Studio, which is kind of what we just talked about, lets you create and query tables visually, but you can also create your own SQL scripts manually. So if I want to do specific things, if I want to manipulate or join tables or do anything like that, I totally can. You can also use the command line. So this is basically, I can do the SQL scripts from a command line, which is really cool. And then lastly, there's Azure Databricks and HD Insight. So those generate and test predictive models. Those are really, really great for large data. So I can manipulate and query my data, and I might use it for like some sort of data science aspect, like HiveQL, R, or Python, which are all like data science, can be used for data science as well. And lastly, your data analyst is going to use something called Power BI, which is basically a collection of software services and apps that allow you to take data and make these really beautiful graphs, right? Really beautiful charts. That way you can show whoever you need, whether it's a customer or your sales team or something, okay, here's an immersive experience for you to dive in. And if you want to click this, this changes based off of this. So Power BI is the tool that data analysts can use. And within Power BI, you can make bar and column charts to show, these certain categories. You can make line graphs, which are great for financial transactions to show trends there, even like of a stock, right? If I want to pitch to buy Dogecoin, I might have a line graph to sort of show what it's going and what the prediction might be. I can show matrix where I can show maybe our Q1 and Q2 revenue. And what's really cool about this is I can actually, with Power BI, let's say I've got this overall graph, right? That shows all of the different, like the overall line chart of where we're going. But let's say I wanted to really specifically look at 2017. I can click that, and Power BI will filter out everything else other than 2017 to where my line graph just shows me 2017's values, which is a really, really cool thing. And then also it gives you key influencers. This is going to be a really just a chart that describes the major contributors. So let's say Nordstrom has their, annual sale or I don't know, whatever it's called, semi-annual or whatever it is. I can actually create this chart basically that displays, well, what do I think the largest factors and contributors to my sales were? And you think about maybe a company like the Los Angeles Lakers are looking at this and looking at ticket sales. Well, obviously one of the largest key influencers is going to be COVID, right? And maybe a mandate from the government if, 75% or whatever that is. And so what I can do is I can quickly look and say, oh, this is probably the indicator, or, oh, we dropped it at a different month this time. If we're doing our sale, it was at a different month, or right when this happened, a traumatic, you think of, let's say somebody was running a sale. Let's say Nordstrom was having their semi-annual sale in 2001, the first and second week of September. Well, once 9/11 hit, sales are probably going to drop, right? Because on people's minds, it's not going to be about, okay, I have to go to Nordstrom and get this sale. People are mourning, people are dealing with that. And so that might be a contributor to maybe lower sales of week 2 of the sale. You can also do a tree map. Now, the common thing, and that everybody kind of knows, is a pie chart, but pie charts actually aren't great from a data scientist perspective. They're really hard to visually understand and conceptualize how different things are. And so what we actually use is a tree map. Because it's a square and you can kind of look and you can see ratios. You can go, oh, okay, this makes sense. That green is much, much larger, and I have a better understanding of how it is comparative to like the yellow or the red. So a tree map is much better than a pie chart. Pie charts are kind of hated in the data science world because it doesn't really give you much, even though it's really, really popular. It doesn't really give you much because people can't visually understand, one slice of a pie chart compared to another because it's a circle versus a square. You can also use like scatter plots or, like a scatter chart that kind of shows you where things are. I'm sure you've probably dealt with a scatter plot or scatter chart, in your life, that can just kind of help you visualize and see maybe a larger portion of X amount are here, or et cetera, et cetera. And then you can do a bubble size. And so bubble size might indicate the amount or additional third data that you want to add in together. One that's really popular is a field map. You can kind of think about this, especially when COVID was hitting. You were seeing, vaccination rates, or when people are transmitting or contracting COVID, right? You would see these maps. Now, this one comes from Microsoft in itself, and it actually has something that's really interesting, because this okay, you're looking at this and you're saying there's green and red, but one fun fact is the most common color blindness, I guess, is actually green and reds. And so typically in data, you really wouldn't want to show green and red. One really common one you'll see is blue and orange. Blue and orange are two colors that from a colorblind perspective isn't very common. And so if you can't indicate, if this is green and red, then unfortunately you actually might be colorblind. Sorry if that's the case, you're just learning that. But whenever we're dealing with colors, green and red is not a great one, but you can see, different shading as well. So from like a vaccination rate, just go to COVID, because that's what's been on the news for the last 18 months. And a lot of these charts, might be like a dark blue is the most vaccinated, and then it goes like lighter, and the lighter you are, the least vaccinated, et cetera, et cetera. That's a great usage of like a field map. From a data analytics perspective, we ask a couple questions, right? So like, what happened, right? That's our descriptive analytics. Then there's diagnostic analytics of why did this happen? Why did our sales plummet? Or why did our sales, go through the moon? You think of like Dogecoin. You can say, why did this happen? And it's because Elon Musk tweeted, right? Like Doge to the moon, and all of a sudden it spikes up. And so you can kind of get these understandings of, okay, what is actually happening? Then I can do some sort of what will happen next. So this is predictive analytics. This is where some sort of machine learning might come in handy, to where, okay, I've taken in this data, what is going to happen next? And machine learning can do the predictive and the prescriptive analytics, or what should we do, right? If I alter this and I put more money into advertising here, what is our, what do we think is going to happen? And you might have, cognitive analytics is where you do this self-learning feedback loop, to where you're constantly changing, and how, kind of sets you up to, if I put more money here, or if I, drop sales here, what is our overall value going to be? Cool. That was a lot of information. Any questions on this? If not, we'll jump into our first 15-minute break. Any questions here? Head empty, no thoughts. Love that. Okay. So far, so good. Great. Well, we will do a 15-minute break. It is 10:20 PDT time. So I did share the slides. Let me put them back in the chat. So we will meet back here at 10:35. So you guys have 15 minutes, and we'll pause the recording. Okay, welcome back. Welcome back from that group exercise for relational data. I thought for this next 30 minutes, until we kind of go to lunch, I thought really we could talk about it and process through that. I know that we do have like a game, but we can kind of do that at the end of this entire workshop if we decide to. And so really, I thought it would be a great idea if we sort of walk through the different groups and you guys could share your findings. So does any group want to go, whether you're small, medium, or large business? How about my medium business? Could you guys go and sort of present what you have? Medium business?
Large can bite the bullet if
Yeah, will you, while we wait for the medium business? Yeah, large. Why don't you guys go ahead?
so. To be clear, the question is basically what kind of system we're going with, right?
Yeah.
Yeah, we decided it'd be better to go PaaS because that would be best for a large business. And
Okay.
as anyone who attended last week's workshop, you may remember a group of us were on a similar business. This business is White and White Pharmaceuticals.
Okay.
From our humble beginnings, we've grown to be a business unrivaled in the industry. We specialize mainly in pharmaceuticals, but we have, similar to Johnson & Johnson, smaller companies as well that actually do silverware and, lighters like Bic because, never have enough. So
Yeah.
now that we're a large business, last week we decided to have, we had our own server because we needed privacy. But now that we're large and we have other companies backing us, we can afford to do a PaaS because we need to be able to scale better.
Okay. So question, for your PaaS, you can have your operating system, right? You can have that sort of control.
Yes.
Okay, cool. That's just something that was kind of the big thing there, right? Is the indicator, and this is why I wanted to point that out, is because that's more of a, like for the exam, it might ask you some like little nuancy things. So this idea of you want to ensure you can maintain full OS level control. That one little piece right there is what I would look and say, okay, which one do I need to use? Okay, infrastructure as a service. This is what it comes with. But then here, if you want the OS level control, you have to have your own, right? And so actually, as I'm looking at it, it might be more beneficial if we're reading through, you take responsibility installing and configuring software, such as your databases. Because I know that the platform as a service can provide an operating system.
I think we were going to go with Linux as an operating system because it's so ubiquitous, and then Postgre SQL.
Okay.
For the nearly the same reason, because it's so universal.
Yeah. No, that's a good point. Okay. Yeah. Perfect. Way to go. Like even just looking at this, okay, I've got my operating system here. I can sort of just kind of pick and choose, which is a great thing. The only thought that I would have is, if you remember from, especially Harley, you were here last time. I think Patrick, you were in the last one as well, is for the infrastructure as a service, you provide the operating system. You have to maintain that and sort of run that. And so when we're dealing with this, if I'm looking at it, says you want to ensure that you can maintain full OS level control, that might be something I'd be curious, if that was a question, which one that would lean to, because that full OS level control might be something that leans more towards the infrastructure as a service, because you have to maintain the operating service. You have to have that. And if we're just using, an operating service that's already there, sort of like a software as a service, you might be limited on something you would have to do. So I would probably actually lean towards more of the infrastructure as a service, only because it says full OS level control. But I think your understanding and your, kind of like what we talked about last week, where it can change, right? So regardless of what your business model can be, it can be a platform as a service versus an infrastructure as a service. So well done. Great job.
Fastest business. In a week, we went from small to global.
That's it. Cool.
We're making it, man.
You're doing it. You're doing it. All right.
Candy to pharmaceuticals.
Yeah, there you go. I'm from Albuquerque, so it makes sense.
Yeah, you might be one of our employees.
Or founders. I don't know. Any of the small business or medium business you guys want to go?
Hello. Yeah, I think on with the medium business, I think we can go.
Okay.
Yeah, I think we would go with the PAAS, the SQL database. Just because in terms of the medium business, there's a lot of uncertainty in terms of how much revenues, things, stuff that we'll bring in. To have the flexibility to have without the infrastructure spending on the infrastructures and stuff, but also be able to have enough flexibility to scale up and down depending on the seasons and all that, and let the service side handling all the securities and all that will be very beneficial for us, so we can more focus on just analyzing the data, doing the things that we need to do until we grow into a more big business. Then we can spend more overhead and cost to have our own data infrastructure on site and all the flexibility that we need.
Yeah, no, I think that's exactly correct. I think one of the big sentences here is, but you don't have a large team available for maintenance. When you see something like that, it automatically eliminates infrastructure as a service, right? Because infrastructure as a service is a maintenance thing. And so I think that's exactly right. So you're medium size, so you don't necessarily need the software as a service to, you're a medium size and you want to modernize and scale existing applications. So it's not like software as a service, you're going to borrow applications or subscribe to applications. You already have them. So I think that's exactly right. Platform as a service, I would definitely go for medium there. Way to go. Small business. You guys want to go? Anyone?
Yeah, we were in a small business. We went with, so we had to start a small business from the ground up. So we chose to host our database with using software as a service.
Yeah.
So that way, we might not have enough resources, or we might want to focus more on our business and starting up, our business plan and getting our things from the ground up started. So we might not have enough to get a development team to maintain other hosting strategies. And this also leaves our database to adjust the resources on its own. That way, we don't have to really do that as a small business.
Yeah, I think that's exactly right. Right. Obviously, depending on what your small business is, if you were a small business of data, right, then maybe it might make sense. Like if you had a team of 5 people, but you were all database engineers, and that's what you did, like consulting or something, then maybe it would make sense to have a platform as a service. But for the majority of small businesses, especially a startup, yeah, not having to pay somebody hundreds of thousands of dollars just to maintain and create a database, but just use those tools and instead subscribe to that software. I think that's exactly right. That's exactly what I would go with. Way to go.
Yeah, that's a good point. So like if our business was handling data, then yeah, that would definitely change up the answer. That's a good point to note.
Yeah. Yeah, right. Because companies change. And so even your large business might not be technologically advanced, right? And so, sometimes with a large business, usually you can kind of think about it. And this is more generic. This is not a definitive thing, but large business might be, depending on how big it is, the infrastructure as a service, right? With the medium being more of a platform as a service, and then small business being a software as a service, right? So you can kind of generically think of those. But just remembering that when we're thinking about this, what our business does matters, right? So for a large business in pharmaceuticals, there might be so much money going to a R&D, right? Or developing these new drugs or these new medications that the idea behind technology is not that big of a deal. So they might even, if you had a massive business that didn't really need to worry, you just had data on R&D stuff and you had data engineers, but you didn't need, or you had data scientists, or you had more chemists. Well, then you might even, you could make an argument for doing a platform as a service or even a software as a service. Cause you're like, I just need, this data to be saved. I don't need to manipulate and forecast, blah, 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 blah. We're just a researching pharmaceutical company that is just massive. Right. And so depending on the business type, it will change and can change. So exactly, right? Like if your small business is data engineers and you guys are consultants, we probably wouldn't outsource and pay for something that you could build yourself, right? But not most small businesses. You think of like a coffee shop is going to have different needs than a database consulting company, right? They might have the same amount of employees. They might have, be in the same location, but their needs are different. And that's the beauty about the cloud, is that you can actually sort of fit and mold whatever your business model is. If you need to scale quicker, you can start as a platform as a service, or if you, are super advanced, right? Let's say you had like a world changing data engineering team, like Facebook, their entire top engineers dipped out and met with the Google top engineers, and they made a consulting team of 15 people, but they're the most 15 brilliant in the world. Well, then they might actually just do an infrastructure as a service, right? Even though they're a small business and they only have like 15 people, they still might, because the knowledge and the technology is there, they might use an infrastructure as a service. Now, though, again, those are the niche things, right? Those are the sort of outliers. From a generic standpoint, you can sort of think of small business is typically going to be more of a software as a service. Medium is typically going to be more of a platform as a service, and large is going to kind of wade between the infrastructure as a service and a platform as a service. So cool. Any other thoughts, questions, statements on this? Cool. Well, we normally do a knowledge check here. I'm actually going to save that for the end. It's a fun game that we can play, but I think saving it at the end would be awesome. We had a really heavy morning of thinking, and you guys just had 45 minutes of that. So I want to go ahead and give your brains a break. So we're actually going to break for lunch right now. It is 11:45. So we'll meet back here at 12:45 to get the second portion started. I will be closing this Zoom room. That way I can start downloading this morning's session, and then I can kind of get it uploaded to YouTube as quick as I can. And I need to close the Zoom room in order to do that. So I will be closing the Zoom room, but we're going to meet back here, same room, at 12:45 PDT Pacific time. Cool. Any other questions or statements before we close out for lunch? Cool. And just as a reminder, in order to get the coupon, you do need to be here for the lunch, the second portion as well. If there is something weird, feel free to either email me or, join back in or message me right now. I'll stay in here for another minute or two. If you can't immediately be back here, that's okay. Just let me know. Or if you have something in the afternoon, just let me know and kind of communicate, and we can make a decision there. But other than that, we'll stop sharing. We'll pause the recording.